is Angel. Metric number is 1002.
Hi, my name is Nur Afina. My matrix number is 1010.
My name is Faris. Matrix number is 1064.
Welcome to our video assignment. Today we will be talking about Boeing 737-400 flight deck system. We are from Group 6 and also from class DAM2A.
We will explain about their control, instrument and also their function.
Each of us will explain different parts to help you understand better.
Today, we have three objectives in this video. Firstly, to identify and explain all major flight instruments.
2. To compare traditional and modern display technologies.
Number 3, to demonstrate how the system can improve efficiency and safety. So in the Boeing 737-400, there is basic flight instrument that provide critical information to pilot to navigate safely and control the aircraft. These instruments are so-called 6 pack that have in two form. Number 1 is digital form and number 2 is analog form. The analog form can be used when the digital form is not working. So is this the cockpit for Boeing 737-400, and I will explain about this instrument. First, we have altimeter that measure in feet. It works by measuring the air pressure that enter the pitot-static tube. Altimeter show the aircraft height from the sea level. Next, we have standby altimeter and the airspeed indicator. For airspeed indicator, it shows how fast the airplane is going. The speed is measured in knots, and the airspeed can measure by measuring the difference air pressure. Next, we have attitude direction indicator to show the flight attitude. The blue one is to show the sky and brown to the ground. Next, we have vertical speed indicator to show the so we have vertical speed indicator, which indicates whether the airplane is climbing or descend in flight level. It is measured in feet per minute and maintain the proper rate of climb or descent. Next, we have here a speed indicator, and under it we have RMI, radio magnetic indicator. For radio magnetic indicator, it is provide real-time bearing information to radio navigation station and helping pilots with directional orientation and navigation. Next, we have clock that help to timekeeping for navigation, so pilot can use the clock to calculate the estimate time of arrival, flight time, and waypoint crossing time. Clock also can use for fuel management, which helps to monitor fuel consumption over time. So this is PFD, primary flight display. The PFD combines several traditional flight instruments into one easy-to-read display, giving the pilot essential flight information at a glance. Next, we have navigation display that display the lateral navigation status of the aircraft. The main characteristic of the navigation display is the color screen and the ability to display different modes and functions.
Hi everyone. So my part, I will be explaining about engine indicating and crew alerting system, also known as ACAS for short, in Boeing 737-400. Although Boeing 737-400 use older technology compared to modern class cockpits, its system still provide a centralized way for pilots to monitor engine performance and also system status. Understanding ACAS is very essential for safe flight operation and also during complex situations. The ACAS panel Boeing 737-400 in the center of the cockpit, they use analog style, but instead of the screen one, but it still help pilot to show engine monitors, system condition, and show warning if there's something goes wrong. So the pilot can detect abnormal condition early through the indicator change and warning. The ECAS in 737-400 is not fully digital like you see in the newer aircraft such like Boeing 787 or Airbus A380. But instead, it's a panel of analog engine instruments and system indicator located in the center of pedestal between two pilots. Here, as you can see, here we have N1 and N2 here. It to show fast and high pressure turbine speed. Right here we have a exhaust gas temperature, also for short EGT. Then we have fuel flow to show the fuel flow in the aircraft. And right here we have oil pressure to show the oil pressure of the aircraft. And right here under the oil pressure we have our temperature to show the temperature of the oil. Here we have the quantity of oil to show the quantity that we have in the aircraft when flying. Next one we have vibration levels, and here we have hydraulic pressure to show the pressure of the hydraulic. So for the function of ECAS is to engine monitoring. Pilot will use it to track performance during engine start, takeoff, climb and cruise. The second one is abnormal condition alerts. For example, let's say the crew noticed an abnormal increase in EGT on engine 2 during takeoff. The red needle on EGT gauge will cross the limit mass. Based on the ECAS data, the pilot may decide to abort the takeoff or throttle back and monitor further. The visual cue is crucial for decision making, even without text-based alerts in the modern aircraft.
In the Boeing 737-400, Flight Management System or FMS is one of the key components that help pilots manage the flight. It allows them to enter a flight plan, control navigation, and works together with the autopilot to fly the aircraft more efficiently. Even though Boeing 737-400 doesn't have a fly-by-wire, the FMS is one early step towards today's smart and automated flight system. The FMS in the 737-400 integrates navigation, performance, and flight planning. It works with the autopilot. To manage lateral and vertical flight path. Pilots can enter the flight plan via the control display units that was CDU, and the system will optimize route and speed, reducing workload especially during complex approach or in high traffic airspace. So let's look at a discussion about FMS. First, it can manage flight planning. Pilot can impose waypoint, altitude, and speed using the CDU control display unit. Second, pilot can improve accuracy and efficiency, helps maintain optimal flight paths and fuel usage. So, it also used with the basic digital display, and the FMS sends data to navigation screen similar to what's seen in newer class cockpits. The FMS is a modern avionics system for navigation and performance management. This shows how the 737-400 blends the traditional analog tools with digital innovation, paving for the way to the smart glass cockpit. So let's look at the example. The FMS allows the pilot to enter the flight route from Kuala Lumpur to Singapore and automatically guides the aircraft flight path. So, the FMS is a navigation and automation system under the avionics category. That was the classification. Got it?
Conclusion in this video is the 6-pack provide essential flight information and the basic tool for pilot situational awareness.
For ECAS will help pilot to show engines warning and also warning clearly, and also making flight safer and easier.
And for the FMS, it will help pilots to manage the flight plans and reduce workload.